Vectors can be multiplied, and as a matter of fact, there are three ways to multiply vectors. The first one is the most intuitive and easiest, and it's called scalar multiplication. So, scalar multiplication is multiplying a constant, like c, times a vector a. And so, for example, 3 times 4 minus 7i, oops, I'm still in complex number mode, 3 times 4i minus 7j, okay. And so I have a vector of 4 minus 7j. If I multiply it by 3, I'm simply rescaling it. Rescale it by a factor of 3. It means multiplying here, so it's 12i minus 21j. Very nice. So scalar multiplication literally is just distributing a constant number through multiplication throughout a vector. You just multiply through like that. And so we kind of take it for granted in some of the work you do in vectors that scalar multiplication is that easy. Okay. Two other forms of multiplication. One's called the dot product. And you're going to learn about the dot product in a later video. In a dot product, you're multiplying two vectors, and we indicate it with a multiplication dot. It's important to write the multiplication dot to indicate dot product. And it results in a number. So it gives you a number, okay? And it's actually very easy to compute. And so it's an easy calculation, but it has some fascinating applications, very incredibly useful. So we're going to use the dot product quite a bit in this series on vectors. And and finally, the third way is called the cross product. And I'm not going to show you in this course what the cross product is, but it would look like A cross B. Calculating that's a little complicated, and it generally refers to three-dimensional vectors. Now I have generalized this to any dimensions, but textbooks will only describe cross product in 3 dimensions. So here's how it works. Here's a vector, here's a vector. They're both pointing off in space somewhere. Well, if I were to move them together like this, and if I take their cross product, which is a complicated calculation, it produces another vector that happens to be perpendicular to the other two. So it's perpendicular to both of these. And that has a lot of great applications. And so you would see it, and by the way, it equals to a vector, not a number. So cross product gives you a vector, dot product gives you a number. Scalar multiplication just rescales the vector by multiplying by a constant number. But you would see this stuff quite a bit in Calculus 3. Also, eventually in physics, you would apply this quite a bit. And so there's a lot of great uses for vectors. In another sense, vectors can be more abstract. And so we teach a course here at the college called linear algebra. I'll eventually hope to have a online version of linear algebra. And in linear algebra, one of the major things you study are algebraic structures called vector spaces. And in vector space can be a little more abstract. A vector could be a polynomial, for example. It could be a calculus integration process or something. It's all kinds of ways to define vectors in a more abstract sense. And so it produces some quite interesting and useful mathematics. So anyway, I wanted to introduce the idea that we do multiply vectors, but I wanted to get this one out of the way because scalar multiplication is easy, and we'll tackle this later. Okay, so let's go on to our next topic.